Good afternoon, dear colleagues. My name is Dr. Oleh Lysak, and I am a scientific researcher at the Geothermal Energy Department of the Institute of Renewable Energy of the National Academy of Sciences of Ukraine. Today, I would like to present my research on the topic Analysis of the current state and future prospects of renewable energy in heating and cooling systems in Ukraine. First, let's consider two important documents: the Paris Climate Agreement and the European Green Deal. The European Green Deal, presented in 2019 by the European Commission, aims to achieve climate neutrality for the EU by 2050. Any new member of the EU, including Ukraine, is expected to align with this policy. This makes it crucial for Ukraine to adopt similar initiatives. Climate neutrality, generally defined as achieving net zero emissions of all greenhouse gases or solely carbon dioxide, involves balancing emissions with their removal from the atmosphere over a specific period. According to the International Energy Agency (IEA) annual report for 2023, further progress is required to meet the 2050 net zero emissions goal. The year highlights a lack of state regulation and clear goals as major obstacles for achieving this target. This scenario aims to limit the temperature increase to 1.5 Celsius degree above the pre-industrial level as outlined in Paris Climate Agreement. When we talk about the green energy transition in energy supply, we focus on three main areas: electricity, heating and cooling demands, and transport. Historically, most attention has been given to electricity generation. However, it is important to note that heating and cooling accounts for almost 50% of the EU's total gross final energy consumption. This highlights the critical role that renewable heating and cooling must play in our efforts to transition to a sustainable energy system. We need to give the sector the attention it deserves to meet our climate goals. Let's take a closer look at the share of renewable energy used for heating and cooling Ukraine compared to the European Union and its member states. From the data, we can observe several key points. First, Ukraine's share of renewable energy for heating and cooling is almost 2.5 times lower than the EU's average share. Second, interestingly, Ukraine's share is higher than that of three EU member countries: Belgium, the Netherlands, and Ireland. Third, when we look at the three largest economies in the EU, we see that Germany and Italy have shares below the EU average. France, on the other hand, has a share that is only slightly higher than EU average. This comparison highlights the varying levels of renewable energy adoption across different countries and underlines the significant potential for improvement in Ukraine's renewable heating and cooling sector to meet or exceed the EU average. While there has been a notable increase in the amount of heating and cooling energy generated in Ukraine from 2014 to 2020, this increase is predominantly attributed to biomass, specifically solid biomass. The contribution of heat pumps to heating and cooling energy is also noteworthy but remains marginal. It is important to highlight that no geothermal heating and cooling other than that from heat pumps is generated. Additionally, the amount of energy generated from solar energy is negligible in comparison. On this slide, we can observe the share of biomass in heating and cooling for Ukraine in relation to the total share of renewable energy in heating and cooling, expressed as percentages. Throughout the period analyzed, other renewable sources besides biomass did not exceed 2.5% of the total share. This indicates a pressing need to diversify the sources of renewable energy in heating and cooling in Ukraine. This slide offers deep insight into the share of biomass in the heating and cooling of private households in Ukraine, related to the total share of biomass in the heating sector. Over the period from 2014 to 2020, biomass consumption by heating and cooling was primarily attributed to private households. However, there has been a noticeable decrease in the share of biomass consumption by private households, dropping from almost three-quarters to two-thirds of the total consumption. This slide provides insight into the share of different types of heat pumps based on the amount of heat they generate. It is notable that while there are three types of heat pumps in Ukraine, scientific literature often analyzes just two: air-source heat pumps, equivalent to aerothermal heat pumps, and ground-source heat pumps, equivalent to geothermal heat pumps. Third-type hydrothermal heat pumps can be considered as a part of ground-source heat pumps. A-source heat pumps have the highest share, largely due to their ease of installation and widespread use. This slide introduces the concept of the levelized cost of heat for heat pumps, a critical metric for assessing the cost effectiveness of heating systems. The equation provides that illustrates how LCOH is calculated, considering factors such as capital expenditure, operation and maintenance cost, fuel expenses, carbon taxes, and the discount rate over the system's lifespan. It is important to note that for heat pumps to be considered an economically viable option, they should demonstrate better cost effectiveness compared to conventional heating systems that rely on fossil fuels. The recent surge in fossil fuel prices, driven by the full-scale Russian invasion against Ukraine, has significantly increased the cost of conventional heating fuels. This increase in fossil fuel price has made heat pumps a more economically viable and attractive alternative for heating purposes. This slide highlights the significant impact of the full-scale Russian invasion against Ukraine on the growth rate of the heat pump market. According to a report from the European Heat Pump Association, annual sales of heat pumps in 15 European countries surged by 37% in 2022 compared to 2021. However, this growth was followed by a 5% decrease in 2023 compared to 2022. Several factors contributed to this decrease. Firstly, the stabilization of energy prices in Europe may have influenced consumer decisions. Additionally, some consumers may have postponed their purchases in 2023 to take advantage of expected higher subsidies in 2024. Furthermore, the removal of government subsidies in certain countries could have also played a role in the decline in sales. Overall, these trends underscore the sensitivity of the heat pump market to external factors and the importance of government policies and incentives in driving market growth. There are several key insights emerged regarding the state of renewable energy in heating and cooling systems in Ukraine. First, renewable energy share. In 2020, Ukraine's share of renewable energy in heating and cooling stood significantly lower than the EU average. This highlights the need for further efforts to increase the adoption of renewable energy sources in Ukraine's heating and cooling sector. Second, biomass utilization. The data shows that biomass is a primary renewable energy source for heating in Ukraine, so there is a need to diversify options for renewable heating in Ukraine. Third, heat pumps. While the current share of heat pumps in renewable heating and cooling is relatively small, there is expectation for growth in this area. However, to ensure the accuracy of forecast models, they must closely align with actual market conditions. In conclusion, these insights underscore the need for Ukraine to accelerate its transition towards renewable energy sources in heating and cooling. This transition not only aligns with global efforts to combat climate change, but also presents an opportunity for Ukraine to enhance its energy security and promote sustainable development. Thank you for your attention. If you have any further questions or would like to discuss any aspects of this research, please don't hesitate to contact me as shown in